Hello, everybody. Welcome to my lecture. I'm so happy to record this lecture, the last lecture of this course, and congratulations to all of you. We have made it to the end. We have made to the last chapter. So let's get started. Last chapter, last week of the course. And then we are done, and the holiday season is upon us. So hopefully everybody has some plan to relax and enjoy a little bit before the grind starts again in January. Okay. So that said, let's get started. Okay. So welcome to chapter number 10, which is sort of wrapping up the course. And the last chapter is systems implementation and operation. So basically what this chapter does is it sort of talks about let me take one step back here. We have been going through the system development life cycle. So now we have reached at the last cycle, which is that you're ready to do system implementation and operation, under which you have activities like coding, testing, installation, documentation, training the user who will use that system, and once that system has been of course implemented and installed, you want to support it and provide continuous maintenance. So the key thing to understand from this chapter is that implementation is a pretty big task, and it's not something which can be done in a mechanical way or in a straightforward way. It has multiple steps associated with it and multiple actors, because this is the stage where end users come into the picture, whom you have to train and to use the new system. And the thing is that while you are doing the system development, while you are going through the whole system development life cycle, the project team is of course fully involved in this development, but nobody else in the organization. By nobody else in the organization, I mean, let's say you're doing an internal system development, which let's say your HR people, human resource people will use. So they know that you are doing the system development. They are not involved into it that much. But this is the stage. This is the stage when you are now finally implementing this new system, that it becomes obvious that the change is coming. It becomes obvious that the end user have to adopt this new system. They become aware of finally that what the new system looks like, and then that they have to shift over to this new system, which we will talk a little bit later, how the implementation, how you can do it in what stages. And the other thing to understand about system implementation is that, again, depending on the organization, you might have an experts available to provide help desk support, to provide answers to some technical question about the new system, or trainers for end users, local experts or department experts. All those kinds of support might be available to you, or again, depending on the project size, the project budget, and the kind of client, internal, external, it might be that the system analyst might be going through some of these phases, of all of these phases of creating a user documentation, then training the user, and then finally providing the support. The other thing to remember about the providing support is that the support is ongoing. Once a system development and implementation has been completed, you just do not walk away from the system. The implementation process, or some sort of process, not implementation, the support maintenance is always ongoing. So you got to have a process there to continuously upgrade, update the system or address user requirements or fix any issues with the system which come across once everybody starts using it. And I would say the other important key thing to remember in this stage is that the training you provide to end user is sort of a very key part of making a system implementation successful. So if you provide adequate training to the end users, they will have a more confidence, better buy-in towards the new system, which will result in a successful system adoption. So that's sort of my introduction to this chapter. And as I said earlier, these are all, we will talk about various installation strategies, direct, parallel, single phase installation. And these are some of the objectives we will achieve through through this chapter, through this presentation. Okay, so as I started earlier with my introduction, that system implementation and operation has multiple activities under it, which are coding, testing, installation, documentation, training, support, and maintenance. Let me add one more thing here. A lot of these activities, again, this is my personal view or based on my personal experience or my own experience. Like as a system analyst or as a programmer, as a coder, people enjoy interacting with end users, getting system requirement, doing coding and all those things. But on the other hand, tasks like documenting your new system or training end users or providing maintenance is sort of constrained. Especially documentation might be considered a mundane task and does get sometimes overlooked by the development team. And because of overlooking the documentation training part, I would say in my mind, one of the biggest reasons for a new system failure is that there's not enough buy-in from end user. And why is there not enough buy-in? Because the end user has not been trained properly, or they don't have proper documentation to help them in using the new system. Okay, so moving on. Okay, so let's first talk about coding, testing, installation. And the reason, the thing is that we group these major activities under system implementation. We can group them into 3 categories. So coding, testing, installation can be grouped together because these are the activities which lead to the system going into the operation. Then you can group documentation and training into sort of a second category, because these are the activities which are needed for successful system operation. And then finally, these 3. And then finally, you have maintenance, under which there are activities which are ongoing and which are needed to keep the system up and running through multiple months or years as the need be. So let's start first with coding, testing, and installation. So while we do the coding in this stage to convert our design specification, which we have finalized in ER diagram as well as in DFDs and all those other design specifications. We convert them into a working code, working application, and then we test it. So even though the testing, the main testing is performed during system implementation, but the test planning begins during the analysis phase itself. And most of the time you will see, while we are doing coding, the testing is done in parallel to to the coding phase. And then the coding, testing, and installation processes, all these processes result under several deliverables, which are listed right here. So we have all these deliverables resulting from all these processes. So the code documentation, the code is one of the most crucial activity which we need to do for the smooth sort of operation of the system. And in addition to that, program and system testing results, we also do a user guide, a training plan, conversion plan, what hardware, software would be installed at what schedule which will follow. Then nowadays data conversion plan is also very important, which is again part of installation process. And then if there's any need to do any physical remodeling of where the system will be placed, which sometimes does happen, that you have to remodel the physical facility as well. And just to add a little bit more about documentation, we have to keep in mind that the system documentation is prepared for two different audiences. The one audience is your information system, your IT personnel, whose job is to sort of maintain the system once it has been implemented, who will provide day-to-day maintenance, fix any issues. So they are your one kind of audience. And then the other kind of audience is your end user, who will need that documentation to sort of use that system. So their documentation is more about how to use a certain features, things like those. So documentation is created for different documentation is created for these two audiences we have. And in addition to the documentation, the other deliverables which come from the second grouping, this is the second grouping I was talking about. So under the second grouping, some of the additional deliverables are documenting the system, training the users, supporting supporting the user, which requires a sort of a user training plan, user training modules, user support plan as well. And then reaching the final process under system implementation operation, which is maintenance. So coming back to here, the maintenance is once the system has been implemented, you're maintaining it. And maintenance has sort of an additional step to it as well, and which is of course you are receiving maintenance to, let's say something goes wrong with the system or something needs to be fixed. But in addition to that, maintenance also serves the purpose of obtaining additional requests in the system design, in the system features, or anything additional which is not part of the system, which now the end user wants to be included. And a lot of time, as you can see, the last stage, system implementation operation, where maintenance is part of it. So you obtain maintenance request. So a lot of time the maintenance requests, the new maintenance request, might even result in development of a new system or a new product, or sort of restarting the system development life cycle, which might be needed if the current system cannot be reused or cannot be modified for the new features which has been asked, or maybe there has been a fundamental change in the sort of the use of data or processes which we were trying to accomplish. So there has been some change into that. So sometimes the change in the data collection, the logic, or the business process change. sort of necessitates redevelopment of the whole system. And again, that comes from a maintenance request. But a lot of times, especially in a mature organization with mature systems, the maintenance requests are generally for enhancement of features and things like that. So where you can think of it as a reusing the existing system to produce sort of this new version of a system. So you keep on reusing the previous version and sort of adding new features to it. So that was sort of the main processes under the 7 main processes or activities under system implementation and operation. Okay, so next let's talk about software application testing, which is a very, very important part or a process of system implementation. And most of the companies, I would say, have QA people or a separate department who is involved in software testing. And the key thing to remember is that even though the testing, the actual physical testing, most of the testing is done during the implementation stage, but the planning for the testing, or how we will approach it, or who will be involved and what kind of testing we will do, that starts quite early in the system development lifecycle, like right from the analysis stage. And some of the key test plans prepared are test plans for unit testing, integration test plan, system test plan. So all those are prepared, or you start preparing them at the analysis stage. So in your book on table number, I think it's what's the table 10-3, I think, yep. So table 10-3, it identifies various kinds of testing, which includes the manual test approach, which are your inspection, walkthrough, desk checking. Under these, maybe another coder, another programmer, or a QA person will go through the code and sort of execute small parts of the code to sort of find out errors or any issues with the code. And if they find any issues with the code, they themselves do not fix the code. They just address and say these are some of the issues with the program, and then the programmers or the coder comes back and fix those issues. But the main testing is done via unit testing, integration testing, and then your system testing. So these are some of the main testing processes. Most of them are automated, or we use some sort of tool to conduct such tested. So unit testing is where each module is tested alone, and then the integration testing is where multiple modules are tested sort of together. So unit testing, single module one by one; integration testing, multiple module tested together. And then comes your final part of it, which is your system testing, where all the modules, all the programs, which is part of the whole application, are integrated and tested together. And just the key thing to remember is that we are not only testing the programs, we are also testing the interface which we have developed for interface between modules and programs, or interface for the users. Those also get tested during all these 3 different types of testing. And I think these are some of the main testing which is done by the QA people: unit testing, each unit, integration testing, multiple in modules, and then system testing, the whole system tested together. And as part of a testing plan, a test case is developed, which is figure 10.4 on your book, which looks right here. So which is basically your test case scenario, which tries to mimic a typical use of that system in a normal workplace. So you try to go through all the queries, your path of how data flows, or how you will use that system, and you try to cover the whole spectrum from which might represent a typical use of system to critical or the abnormal use of the system. So you're trying to cover every kind of possible use of the system, so covering the whole spectrum from typical, critical, or abnormal use. And you develop these test cases, and their results are documented for the application. And then finally, once all your test case, all the testing is done, of system testing is done, the last test is called the user acceptance of the application, or it's called acceptance testing. So the acceptance testing sort of determines if the new system which we have developed meets user requirements. So that's sort of the goal of it, that we have fulfilled all the requirement, all the features as requested by the user and as we signed off on. And the acceptance testing includes both alpha testing and beta testing, and sometimes system audit as well. Okay, then finally, now the testing is done. We have done acceptance testing where user maybe brought their own data, or they inputted all the data into the system, or the system was tried with live data. So once all that has been conducted, we are ready to now go through the installation of the new system. So okay. So how is installation of a new system done? So installation can be done in 4 different ways, as you can see here. And what are those 4 different ways? Direct, parallel, single location, and phased. So what's the difference between all these 4, or how do we do all these 4? Okay, so let's look at this 4 different kind of installation. The first one is direct, which is A. So under A, you have the current system. We install the new system, and then we say from 1st January 2020, everybody will move to the new system, and the old system will be shut down, closed, or not available. The good thing about this kind of approach is that it sort of forces everybody to be prepared and to move to the new system right away. But the downside of it is that it's so abrupt, and there is no sort of a backup available. So if the new system fails, and especially if you're using it to take customer orders or dealing with your clients, if the new system fails, what you're going to do, there's nothing at the backup to go back something to, and then if you do need to restore your old system, that's going to take some time. So there's always good and bad side to direct installation. Most of the bigger installations or bigger systems, I would say you do not go through directly with the direct installation. Then you have B, which is parallel system, which is right here, this one. So under that, you install the new system. Sorry, you have the old system, you install the new system, and then you say from 1st January to 2020, the new system will be available, and then the old system will also be available for the next 1 month. So for the whole month of January 2020, starting from the 1st January till, I don't know, January have 30 days or 31 days. So for the first 31 days, both the systems will be available. And then after 30 days of both systems working parallel to each other, we will shut down the current or the old system. So the good things about it is that under such installation, you have both the systems available. You know, if something goes wrong with the new system, your clients or your end users don't get impacted. You get the feel of both the systems and how it's easier to sell, how the new system is better than the old system. The downside of it could be that you're duplicating your efforts for the whole 1 month. So for the whole 1 month, maybe you're entering the data twice, or you are going through two processes or two forms for the same thing. You're duplicating your work, which can create some confusion, and it could be that most of your users of the new system might not even touch the new system for the first 15-20 days, because they know, oh, we have the old system still for 30 days. Let's wait for the last 1 week and then we will move to the new system, or maybe till the end. And in such case, the parallel installation becomes exactly like direct installation, because everybody waited till the end to move to the new system. So that's sort of the downside. But again, in my experience, parallel system is still, installation is much better, especially when you have external sort of exposure, where your application, let's say you are an insurance agent or something like that, where you have your external clients involved as well. So you got to need some backup if the new system failed. Then you have your single, which is C, your single location installation, which is applicable for, let's say you have multiple locations of your offices or where, you know, that application is going to be used. So you first start with one location, with one franchisee or one factory, and see how that implementation works out. If there are any kinks, you get those kinks removed. And then you can, the other thing is that then you can sort of concentrate or put all your resources on one location. What do I mean by that? Let's say you have 5 locations, 5 factories, and you are sort of implementing a new system starting from January 1st, 2020. So if you are doing it in all the 5 locations together, your system support people, your MIS people, your user supports people will have to now support all these 5 locations. Instead of doing that, let's just start with one location in Cleveland and put all our resources as a help for just one location. So just to make sure that at that one location, they have all the help available. We get all the kinks, all the issues taken care of, and the system implementation is a success. And then that success can be now transferred to your other 4 locations physically, as well as, you know, by advertisement or just by word of mouth, that it was successful at one location, end users at other location also feel comfortable using it. And it's easy to convince your other location about the success of the new system if you have proven it that the system works at one location. The downside of it, just like your parallel installation, in a single location installation, your IT people would be supporting the new application at one location and old application at your other 4 locations. So that's sort of the burden on them. And some other issues which might arise is if all these 5 locations are sharing data among them, or there's some sort of data transfer happening. So what are you going to do with this Cleveland location which has migrated to a new application, but all the other 4 locations are using still the old application? And another downside is if there are a lot of issues with the system implementation at the Cleveland location, that word also gets out at other location that this new system is very difficult to use or has a lot of issues with it. So so that's sort of the downside of it. And then finally you have your phased installation, which I think is one of the most popular ways to install a new software, especially when you have multiple locations. So under phased installation, instead of concentrating on one location, you sort of, what you do is you release your new application in an incremental way at multiple sites. And so the addition of, or the release of the application is done in an incremental stage, gradual manner. So you are incremental one functionality at it at a time. So that's what the phased installation does. And one of the key benefits of this is, since you are releasing your application in a phased incremental manner, so maybe 25% of the application will be released on January 1, 2020. What that also means is that the 25% of that application needs to be developed and tested by January 1st, 2020. So what that means is that your system development can also be done in a phased way. So the phase which you are releasing early should be developed first, and so on and so on. So it sort of reduces the burden on the system development team, as well as makes the development faster, because rather than now that developing the whole application, you are developing it in an incremental way. So this sort of limits the downside or any errors as well, and sort of reduces the risk. The downside of this is that you got to have a good compatibility between the new partial application which you are releasing and the old one, the existing one. Because let's say if you are releasing 25%, then another chunk of 25% of your application every 3 months, it still has to work with the old application. So you need to have a good way of converting the data, or data being able to travel between the new and the old application. And sort of this conversion of data or business processes between old and this incremental release of new application is sort of constant till the time you have completely released the new application, which sometimes again causes a little bit of frustration and headache for the IT team as well as the end users. So that's sort of various installation strategies. Moving towards documenting the system. So for system documentation, we generally generate, or each system needs system documentation and user documentation. And your system documentation provides quite detailed information about system design specifications, its internal workings, its functionality. And to do this, we use both internal and external documentation. And then you have your user documentation, which is created for end user as how to use an application or how does it works. And most of the time this is done, well, nowadays everything is online, so it's done in a much more, it's an online user documentation, which could be combined with videos, with hyperlinks, links to your various websites, which user can click with a pictorial tutorial opens up, or a video open up as how they can use a certain feature of the system or troubleshoot something, some part of the system. So that's generally part of the user documentation for users. And then we have done with the implementation, we have created user documentation. Now the time has come to train our end users. So your user training, depending on what kind of application it is and what kind of end user or what purpose they're using it for. It could be on different topics, different areas. Something as simple as use of system. Let's say we just launched Blackboard. So user system would be, how do I register for a new class? How do I see my grades? Things like that. General computer concept could be, which nowadays we don't have to do that much. That how do I open a web browser? How do I copy a new file, new data, download a file, things like that. Information system concepts might be, not every end user might need them, like how do you do batch processing, things like those. Organizational concept is which are related more with business processes. That organizational concept could be that before taking MBA 545, for example, you have to take MBA 535 or some that's in with a web advisor concept, or if you're in an accounting firm, something to know about debit, credit, FIFO, first in first out kind of things. System management could be that you need a new feature or something is not working. Whom should you approach? How do you open a ticket? How do you get an issue fixed with the application? And then finally, system installation is which generally has to do with when you're installing a new system. How do you get started with it? If the old system still exists, for how long does the old and new system will coexist? Or if a certain part of the new system has been released, how will that new part of the system will talk to the whole old application? So things like those. So those are part of the training. And then these are the various methods of training. What I have seen nowadays is, and again this is my personal opinion, a lot of the training generally gets outsourced to various professionals who have a lot of teaching experience, or who are good in addressing user concerns. There are a lot of automated pre-recorded videos available, which are provided to the employees, or you bring in some experts from outside whose whole expertise is teaching new features or how to use a system. Because generally you cannot expect that your IT people who are programmer, tester, or analyst, that they can all of a sudden become sort of a teaching expert as well. So you generally do bring people from outside who are a little bit more, have skill sets in teaching. So that sort of covers all the processes, or that sort of covers the whole system implementation and operation and various processes under it. The last thing I'll talk about is that why sometimes a new system implementation fails. So generally, they say 50-60% of the new system implementations do fail. And I know this number is a little bit exaggerated, because the reason for that is, let's just say if 50% of new system implementation fail, that doesn't mean that if a system implementation fails, you're done with it, you start from zero. No, you go back and you address the issues which were with the last system implementation. You fix those issues and sort of do the re-implementation again. But going back to some of the reasons for implementation failure is, I would say that lack of buy-in, lack of support from the top management, because management are the one who are going to drive through the sort of the implementation of the system, and then they will make sure that people or employees or mid-level management do accept the new application and use it. So you got to have a sort of a sponsorship from the management, from the top management. A champion somebody has to champion the new application. Same way, the other end, you got to have a buy-in from end user that the new application which has been developed is not meant to increase their work, is not meant to have result in layoffs in the company. It's made to make them more productive. It's there to make their job more faster. But yes, but that's true. A lot of time, any user feel that the new application is been made to make, in the worst scenario, to have layoffs or to make them do more things than what they are doing. And that's where you need user buy-in, all the way from user requirement gathering to training, to show them that what's the purpose of the new application. Okay, I think there are a couple of more pages which I'll ask you to read about maintenance, as well as website maintenance, especially if your application development includes a website, because the thing with website is websites are 24/7, 365 days a year, and you cannot do sort of a phased release of a website, or you cannot say, like, let's say if you're Amazon, you cannot say, hey, we will be down for 6 hours today because we are bringing out a new version. So that sort of adds a little bit more complexity with the website. Okay, so that's it for this chapter. Take care. Bye bye.